block and our calibration test kit. So first, maybe we can zoom up here on the block. This is the test block that would be installed on a compressor package. We'll have discharge pressure coming in from the compressor into the block, and then the high pressure cutout would be installed on the outlet line from the block. And then we have a test port. On the test port, we will be using our calibration pump in order to test the high pressure cutout using oil pressure. So let's go look at the test pump. Okay, so here's our plastic carrying case that goes with the test pump. And here we've got our calibration pump, so we'll just take this out of here. And you get a shot of it there if you want. See what that looks like. And wipe just a drop of oil off of it. And also in the test kit is our calibration hose. These are special hoses that come with the pump. They're quick connect hoses. And one thing you'll notice as you look at the hoses, the two ends are different. The longer end is the one that goes into the test block. The shorter end is the one that goes into the calibration pump. We recommend that you're wearing your proper personal protection equipment anytime you're using a calibration device. So you see I've got on my safety gloves, safety glasses. So the first step after we've got the calibration pump out is we have to remove this quick connect. It's really just to keep the pump connection clean. And then we can install the test hose, and that would be the short end of the test hose, into the calibration pump. So we insert the connector in, push it in until it clicks, and then we're ready to go on that end. Now the next thing we'd recommend is adjustment of these two devices. You've got a bleed valve that should be closed. So we'll close that all the way. And there's a vernier, which you might want to feel the full range on it. And you'd like to have it set roughly in the middle of its range. So we'll come out to there and we'll go in a few turns. We'll say 2 or 3 turns in should be fine for the initial setting. You need to turn the gauge on. So we press enter here. And we let the gauge come up to be powered on. It goes through its little test sequence. If it doesn't come up to 0, as you can see, mine's coming up to about 0.6 psi, and you can press the 0 on the gauge, and it will recalibrate for differences in atmospheric pressure. Okay, so at that point, our pump is pretty much ready to go. Now, I'd already put oil in this. I should show that part. There is the pump is made to be used with refrigeration oil, and we recommend that whatever oil is being used in the system that you're to calibrate, that you can use that in the calibration pump. So you have to remove this little plastic plug. I'll set that aside. We've already put our refrigeration oil in a small bottle here to make it easy to fill our pump. And then we will just put refrigeration oil up to the fill line in the pump so that we're ready to go. So there's pretty much full. At that point, we'll stop, and we'll put our plug just loosely back in the hole. Doesn't have to be real tight. So that's pretty much ready to go at that point. Now the other thing we have to do on any initial use of the hose is to get the air out of it. We don't want air in the hose when we start the calibration process. So to relieve that, well, first I have to show back here. The pump has 2 positions. It has a very short stroke position, which is actually called the pump mode, and there's this silver button here, which I'll turn it around this way. You can see if you push that forward, you get a much larger stroke than on the pump as you pump it. That's the position you want to be in when you're just starting out. Okay, so we're in priming mode there. I'm going to use a rag here on the end of the hose. And I'll let him zoom in here. There's a little check valve right on the end of the hose that if you push that in with your finger, as you pump with the pump, you should begin to see oil coming out of the end of the hose. Now this is important because you don't want to trap air in the hydraulic hose. It makes the possibility of pushing air into the refrigeration system, which we don't want. We'd rather have just oil during the calibration. So we will pump with this little button release until we see some oil coming out there at the end of the hose with no more bubbles, really. Okay, and I'm going to say that's probably enough. And then I can release the button and that will trap the oil in the hose, and then we're ready to go. Then down here a second. Wipe a little bit of the oil off. Okay, at that point we're ready to plug our calibration pump into the test block. Now we're going to recommend that at that point the test block be switched from the run position, which is this way, to the test position, which is this way. To release the block, you just push in on the little locking mechanism. So now it's in the test position, and now we'll engage the quick connect into this device. And also it clicks when it locks in. So now in our test setup today, we have a Rosemont pressure sensor that is simulating our high pressure cutout. On a real compressor system, this would be your high pressure cutout, or the transducer that's probably indicating discharge pressure and wired into control panel. It would cut out the machine as you come up to pressure. So we will be creating that pressure with oil pressure now to bring us up to the point that will cut off the compressor as we test the high pressure cutout. So now once we're to this point, we can begin to pump on the pump. I'll turn it around this way so you can see it. And I will have to pressurize the lines that are involved. So that will also include, in our case, this line that's going over to the high pressure cutout. So we'll have to compress any gas that's in that line. Sometimes this can take a few pumps. It can take a little while. It depends on if the pump has been used before and if everything is all primed up. The pump works better if you just pump slowly so that you give the plunger time to fill on each downstroke. You'll deliver more oil with each pump if you do that. So just a little patience, and we'll keep pumping here for a while until we start to see the pressure coming up. Okay, we have two different pressure transducers here you can see. This one is showing discharge pressure, which we have it disconnected to a nitrogen bottle, but you can see it's reading about 111 PSI. That's actually A. And then we have a second transducer that's simulating our high pressure cutout, and it's reading approximately the same pressure in PSIA. Now as we start to do our calibration and we start to pump up with oil pressure, we will build pressure until we come up to the point that we equal the system pressure, and at that point then the calibration pump will start to take the high pressure cutout above the system pressure, but not until we get up to that level. So you can see with each pump I come up a little higher. I'm about 80 pounds now. Here's 97, 101. So now again, this device is set engage, and my transducer is in absolute, but at some point here you'll see that the pump will start to take over right about there. Now I'm starting to raise the pressure on the high pressure cutout, and you can see as this device is pumping oil pressure into the system, I'm starting to raise the pressure at my high pressure cutout. Okay, so now the rest of the way we're just raising the pressure on the hydraulic fluid. That particular one will not go up. That's the discharge pressure, so it's not going to feed backwards over there. Now we're going to simulate a high pressure cutout at 225. Let's see, I guess we'll do it in 225 PSIG, which will actually be about 230 over here. So as you see, as I get close, now one thing we need to do with this pump is as we're approaching our pressure, we're going to push in this button that will take us out of the priming mode into pump mode, and then the stroke on the pump is a lot less. But that allows you to slow things down so you can gradually approach the pressure. Now you can see it, I'm already at 220. I said I'm going to set it for 225. So if I just go a little bit more, okay, there I'm at 221. Once you're close to the cutout pressure, you can use the vernier dial on the pump to raise the pressure a little more. It just takes some dead volume out of the pump. So I can raise it maybe 3 or 4 psi is about all, and it'll come up slowly so you can approach your high pressure cutout on the system. Now I just ran out of travel here, which means I'll have to back this one off and I'll have to give it another little pump. Alright, so back the vernier off, I'll give it a little bit more. Alright, there I'm at 223. I'm trying 225, so I probably can get there now. 223, okay, so now I'm getting real close. I said 225, so there's 224. And I can bring it right in to 225. Should be able to with the vernier. Okay, there, just right about at the set point, or I'm jumping around it there just a little bit. Pretty close. But the intent of this is when I reach the cutout set point on my calibration pump, I should also reach it on my transducer, and the machine better cut off. So you're sitting here, this would really be a control panel in the real engine room. Once I hit my cutout set point, I need to hear that compressor stop. That's a requirement of the code to prove that the high pressure cutout works. If it doesn't cut out, then you've got work to do on your control panel to go make sure this high pressure cutout is set correctly, or to recalibrate it in the panel so that it is in calibration with your master gauge. It's important that the gauge used on the calibration pump be calibrated to a NIST standard gauge. We use a dead weight tester here in the lab. It's traceable to NIST, so we set the calibration just before we start. In an operating plant, you would probably need to send your gauge out and get it calibrated maybe once a year and keep records of the calibration. So at that point, we're pretty much finished. Let's say our machine cut off at the right pressure, and we're happy with that. Now we can complete our test. So, now this part you have to be a little thoughtful about because you have high pressure oil now in this hose. And there are check valves in the hose that will trap the oil in the hose. So when we're done with our testing, the first thing we can do is actually remove this cable. And it will trap. So the check valve will trap the pressure in there. Now you see, I still have got the pressure in the hose. Okay? As far as my system is concerned on the test block, I'm going to switch that back to run position so that the machine, so basically the pressure now on my high pressure cutout will read real system pressure. It's not reading just the false oil pressure that I pumped into it. One advantage of this test method is this block has a check valve in it that if a real high pressure occurrence happens while you're doing the calibration, the check valve opens, the high pressure still goes through the high pressure cutout. It will still cut the machine off, even if I'm only part of the way through the calibration. So that's partly what makes this such a safe method. Okay, so now I've just got to get rid of the pressure in my hose. Now I was very careful in doing this, so I'm pretty sure I have no ammonia in my system. There's actually a check valve here that would keep gas from coming into the hose, but I've got 193 psi worth of oil pressure. I can relieve that back to the reservoir in this tank, but I have to do it kind of slowly using this bleed valve on the bottom. So if you just crack this needle valve, you can slowly see the pressure drop. You just don't want to do it too fast, because if there is any air in the system, you'll foam this little reservoir, and you can get oil sprayed all over you. So I'm going to do this kind of slow until I start to see the pressure drop. There it goes. Okay. And once the pressure is relieved, I'm pretty much good. I can close my bleed valve again. And if I'm doing a series of calibrations, I could take this just the way it is and go on to the next machine and calibrate the next machine. If I'm done for the day, then I can remove the quick connect here at the pump, like that, and put my my protective plugs back in, turn off the gauge, and we're ready to store it. Now, you might want to drain the oil out. This can get a little messy if the oil drains out in the carrying case, so you can drain the oil out into a suitable container if you're going to be storing it for a while. We also don't recommend changing oil. I mean, one of the reasons we use refrigeration oil in the system is so that little bit of oil that I put in the high pressure fed out line, when I pumped it up, will just run harmlessly back into the refrigeration system when I put this in run position. So it drains that little bit of high pressure oil out. There's no air introduced to the system, and there's no risk of leakage. But then we don't want to switch the oil that we use in the pump. There will be different O-rings in the pump depending upon the refrigerant that it's used on and the type of oil that's used. So generally we would say whatever your most common ammonia refrigeration oil is, use that in the reservoir and then don't switch it to something else. Use that same oil all the time. And I think that's it. And thank you very much for your attention, and we hope you appreciate this as a method of calibrating your high pressure cutout.